All right, we're on homework 36. And the first problem says to set up and evaluate the integral that gives the volume of the solid formed by revolving the region about the x-axis. So for any of these, if you're not provided a graph, you should sketch the graph so that you know what's top versus bottom or left or right minus left. So they've given us the little representative rectangle here. Remember, that represents your radius of rotation. So the radius here is going to be top minus bottom. And so that's going to be negative x plus 1 minus 0. And I always make a point to do the minus 0, even though that's kind of silly, because eventually we will start rotating around lines other than an x or a y axis. And so the number of where that line is will be important. So anyway, it's negative 1 plus x, or negative x plus 1, and maybe we'll simplify that then to 1 minus x. Okay, and then our volume formula is that volume is equal to pi times the integral from the x bounds, 0 to 1, of r squared, so 1 minus x squared dx. And we could use a calculator to solve these. When we have a quiz, it will be calculator, but that's not to say that you wouldn't find problems like this on the no calculator. So I went ahead and did these without a calculator because it's good practice. So, here I am getting ahead of myself though. I can't just start integrating this. I guess I could with u sub, but I would rather square this out. So this is going to be 1 minus 2x plus x squared. There we go. Now I can integrate. So the integral of 1 is x minus 2x squared over 2, so minus x squared plus x cubed over 3, evaluating from 0 to 1. And then when we plug numbers into this, when we plug in 1, we get 1 minus 1 plus 1/3 minus 0. Again, I always like to make note of that in case there's something that doesn't come out to 0 when you plug 0 in. 1 minus 1 is 0. 1/3 times pi is pi over 3. So there's our first volume. Okay, for number 2, same idea here. So the radius is going to be the top minus the bottom. So the top is the function 4 minus x squared, and the bottom function is just 0. You're always connecting this rectangle to the axis of rotation. So they've done it for us, but again, if you're drawing your own picture, you connect the function that you're rotating around to the axis of rotation. So the volume is going to equal pi times the integral from 0 to 2, just looking at where the graph is marked off, of r squared dx. If I'm not using a calculator, I should square this out because u sub would not work in this case. You do need to square this one out. U sub would have worked here because du dx would be negative 1, and you can adjust for that. Here du dx would be negative 2x, and I can't adjust for that. So this is going to be squared out 16 minus 8x squared plus x to the 4th. And then I want to integrate that. So this becomes 16x minus 8x to the 3rd over 3 plus x to the 5th over 5. Math is going to be a little bit cumbersome to work on here, but let's see what we can do. So when you plug in 2, you get 32 minus 8 times 8, so 64. 64 over 3 plus 2 to the 5th is 32 over 5 minus 0. Now, you could get a common denominator of 15, which I do want to do, but I don't want to do all of the large number math. Like I am going to get this all over 15. But I want to do some adjustment here. So the 32 will get multiplied by 15 over 15. Okay, 3 by 5 over 5. 5 by 3 over 3. But I want to rewrite. I'm noticing that all of these numerators are in terms of 32s. So we have 15 times 32 minus, instead of 5 times 64, 64 is 2 times 32. So that could be 10 times 32. And then plus 3 times 32. Instead of doing the math of 15 times 32 and 64 times 5 and 32 plus 3, I'm just going to say, like, combine like terms here. How many 32s do I have? 15 minus 10 is 5. 5 plus 3 is 8. So now I just need to do 8 times 32. And before I do that, I'll do a quick check for common factors. I don't think there are any common factors between 8, 32, and 15 that I could reduce. So let me just do this off to the side here. 16, 24, 25. So that's 256. 256 pi over 15. So maybe that's a way that you don't always think about, we don't always think about adding fractions like that, but I just noticed that the numerators had that common factor. And if I can avoid doing a lot of large number math, then I will. Okay, here's our next function, square root of x. So r is equal to top minus bottom, square root of x minus 0. The volume is pi times the integral. This one goes from 1 to 4. And then it's r squared, so square root of x squared dx. So simplify that before you integrate. Square root of x squared is just x. So that's pretty easy to integrate. This becomes x squared over 2, evaluated from 1 to 4. So plug in 4, you get 16 over 2, which is 8, minus 1 over 2. So 16 over 2 minus 1 over 2 is 15 over 2, so 15 pi over 2 for that volume. All right, for my next one, the square root of 9 minus x squared. We talked about this a bit in pre-calc about that's a half circle, so we're just looking at a quarter of it here. The radius is, again, top minus bottom, so square root of 9 minus x squared minus 0. And then the volume is pi times the integral from 0 to 3, according to the graph, of r squared. So again, this is another square root of 9 minus x squared squared dx. Now, if you don't show that step and you just simplify it right away, that's perfectly fine. I'm just doing it for the homework. When I square the square root, I'm just left with the expression underneath. All right, and then let's integrate this. So 9 becomes 9x. The antiderivative of x squared is x cubed over 3, evaluated from 0 to 3. When you plug in 3, you get 27 minus 27 over 3. So 27 divided by 3 is 9. Oh, minus 0. And then that's, 18 pi? We could have also, without calculus, I could have also said this is a quarter circle. So 1/4 times pi r squared is, oh wait, no, what just happened there? 9 pi over 4. Did I do something wrong here? 0 to 3. Pi r squared. 9 pi over 4 is not the same as 18 pi. So what did I do? Let me check my other answer key. Did I mess up somewhere? Nope, I got 18 pi. This is definitely a quarter circle, though. We'll have to figure this out. Someone tell me where I'm wrong when I get into class here, because I'm not seeing how I'm getting different solutions here. This is a quarter of a circle, right? Yeah, I think so. We will I'm going to be double checking that one. All right. Well, anyway, geometry should work for us there. It's too early to be thinking about this. I'll come back to that. Okay, set up and evaluate the integral that gives the volume of the solid formed by revolving the region about the y-axis. So now we're going sideways, and again, you can see that the rectangle they're talking about is already shown for you, but if you're revolving around the y-axis, that means you're reflecting across the y and forming this 3D shape. So the first thing you need to do is solve the equation for x so that it's a function of y. So this would be plus or minus the square root of y equals x. And now it's not really plus or minus. You have to choose which one. And remember, this is x equals. So look at all of the x values on this graph. The x values go from 0 to the right. So x is positive on this graph that we're looking at. So that means that x is only equal to the positive square root of y. All right, so r is right minus left. So that's going to be square root of y minus 0. Left is the x equals 0 line. And then the volume is still pi times the integral from, look at the y bounds now, so 0 to 4. Everything should be in terms of y, of square root of y squared dy. Right, so that is just pi times the integral from 0 to 4 of y dy. The antiderivative of y is y squared over 2. And if I plug in 4, I get 16 over 2 minus 0, so that's 8 pi for this volume. Okay, here's another. Oh, duh, you know what? Sorry. I was thinking area on this one. Okay, okay, things are fine. Area is 9 pi over 4, but I wasn't finding area, I was finding volume. So, okay, that explains that. Goodness. All right, so yeah, so why isn't it equal to 1/4 pi r squared? Because that's just the flat surface area. If it asks for the area of this figure, you could just do that. Because we wouldn't have a way to integrate the square root of 9 minus x squared anyway without having the squared on it. So, okay, anyway. Number 8. So again, here's another one of these. This is not an area question, it's a volume question. So I need to solve this equation for x, first of all. So y squared will equal 16 minus x squared. I want to solve for x, so I'm going to add x squared over here and subtract y squared to the right side. And then square root, and yes, technically you get this plus or minus thing happening. But again, x is positive. So x is really just the square root of 16 minus y squared. They usually do give us graphs in the first quadrant, but if the graph is in any other quadrant, you're paying attention to, well, are the y values or the x values, whatever the equation is solved for, are they positive or negative? So that's how you can make that decision for the plus or minus. It's not necessarily always positive. Okay, so r is equal to right minus left, which is the square root of 16 minus y squared minus 0. And volume is pi times the integral from 0 at the bottom to 4 at the top of the square root of 16 minus y squared dy. Clean that up. And we can integrate. So the antiderivative here is 16y minus y cubed over 3, going from 0 to 4. And let's see, plug in 4. That would be 4 times 16 is 64, minus 64 over 3, minus 0. So again, I would just say, like, I mean, I guess you could do 3 times 64 minus 64, but I would just say, well, this is going to be 3 times 64 over 3. And so 3 times 64 minus 64 is now just 2 times 64 over 3. And that math is just a little bit simpler, I think. So 128 pi over 3. Even though our quiz is going to be all calculator based, this is just kind of good practice and exercise for your antiderivative and just number crunching skills. Okay, number 9, x to the 2/3. So first solve this for y because we're going right minus left. That means you need to raise both sides to the reciprocal power, so it's y to the 3/2. Now technically there is a plus or minus on that because this means the square root of y, and then you're cubing it. But again, y is just going to be positive. I'm sorry, x is going to be positive, so therefore y is going to be positive. All right, so let's see. So r is equal to y to the 3/2, right minus left, minus 0. Volume is pi times the integral from 0 to 1 of y to the 3 halves squared dy. So that's just y to the third. When you do power to a power, you multiply your exponents. Okay, and then we integrate that, so pi times y to the fourth over 4 from 0 to 1. That's just going to be 1/4 minus 0, so it's going to be pi over 4. Okay, last problem. Now, how do I solve this? Oh, sorry, I don't have to solve. I was just going to say, how do I solve this? It's already solved in terms of y for us. This would be really hard to get in terms of x, so like to solve it for individually for y, so we're not going to do that. So r is equal to negative y squared plus 4y minus 0. And the volume is pi times the integral from 1 to 4 of, I'm going to write this as 4y minus y squared, the quantity squared, dy. We've got some squaring to do. So 4y times 4y is 16y squared. 4y times y to the third is, 4y times y squared is 4y to the third. There's going to be two of those, so minus 8y to the third. And then y squared times y squared will be plus y to the fourth. And when we integrate, this one comes out kind of ugly if I remember correctly. 16 times y to the third over 3 minus 8 times y to the fourth over 4. So let's make that minus 2. 8 over 4 is 2. And then plus y to the fifth over 5. Going from 1 to 4. So this one has quite a bit of computation. Like I said, it's good for you, so I suppose I should go ahead and do this. So 16 times 4 to the third over 3 minus 2 times 4 to the fourth. So 4 to the third is 64. 4 to the fourth, I need to multiply that by 4, right? 16, 256. So that's 256. And then 4 to the fifth, that's, let's see, 24, 22, 1024 over 5. And that's just plugging the 4, and then you have to remember to plug in the 1. So, okay, 16 thirds minus 2 plus 1/5. Usually when I'm doing this math, I try to combine my like fractions a little bit instead of getting common denominators everywhere. So like 16 thirds times 64 minus 16 thirds. So again, how many 16 thirds do you have? You have 63 times 16 thirds, right? 64 minus 1 times 60 thirds. Okay, and then minus 2 times 256 plus 2. So let's see, what is 256 times 2? That's 12, that's 11, that's 512. So negative 512 plus 2 is going to be negative 510. And then subtracting 1 from this, I get 1023 over 5. Okay. And then common denominator here. Now, I don't see any nice common like, oh, they're all 32. So I think I am just going to go through the trouble of multiplying stuff together because, again, why not? All right. So this needs to get multiplied by 5 over 5. You're by 15 over 15. And you're by 3 over 3. So here we go. 16 times 5. That's going to be 80. 63 times 80. Put a 0 there. 8 times 3 is 24. 8 times 6 is 48. Plus 2 is 50. So this is 5,040 over 15. Minus, what's 510 times 15? That's 0. That's 5. That's 25. Placeholder there. 0, 1, 5. Maybe I've screwed up somewhere already. I don't really know. We'll find out. By the way, on the AP test, would you be needing to go through all of this? No, I'm doing this purely for brain exercise here. Okay, so let's see. So I'm going to subtract these. So 7650 minus 5040, and I'm going to know that my answer is negative because I'm subtracting backwards. So that's 10, 6. That's negative 2,610 over 15 plus this. That's 9, that's 5. Got to borrow there. Do make that a 10, 4. That's 459 over 15. This answer does not look familiar to me. There's a pi in there too. Pi. Let's see. What did I get when I did this the first time? Oh, no. Oh, wait. Can I? Oh, no, I can't. Okay, so I got different answers. Somewhere did I mess up? Possibly. Let's see. 5,040 was in there. Yeah. And then I got minus 450 here. Oh, because I only had 2 times 16. Oh, but 4 to the 4th is not 16. I think my answer might be right. How about I check this on my calculator? Look how much life is easier if you just get to use a calculator. So if I am allowed to use a calculator, I go all the way back here and I say pi times the integral from 1 to 4 of 4x minus x squared dx. That's that answer. My answer, what was my answer? 459 pi over 15. We cross our fingers. Hey, okay, so this is the right answer. I'll have to fix the first time I did it, I must not have checked my answer there. Okay, so that was a bunch of fun brain exercise. But like I said, even if this were non-calculator, you're not really required to simplify your answers from what I've been told. So how far would you need to go? Honestly, I don't know. Like, could you stop right here? Could you stop right here? I don't recall having to crunch this many semi-large number values just for an AP free response question. So I'm not too worried about it. I encourage you to simplify stuff unless you think that you're going to make a mistake along the way somewhere. All right, that finishes this assignment. Please come into office hours if you have questions.